Hello, good afternoon. Good afternoon, everyone. My name is Ben Carlin, and I am here in the COGEN Europe offices in Brussels to introduce this webinar today on REPowerEU, the role of energy efficiency. And of course, it's extremely topical that we're having this webinar today. So just in the last hour, the European Commission has been issuing its proposals for how it plans to reduce the consumption of fossil fuels in the European Union in the coming months to reduce reliance on imports from Russia and also over the longer term. So we have a very full and interesting and informative webinar prepared that will take place over the next 90 minutes. And we will start with an introduction from my colleague, COGEN Europe's Head of Policy, Alexandra Tudoroiu. And Alexandra, are you there?
Yes, good afternoon, everybody. I hope you can hear me and see my slide.
I can't hear you. Can you hear me?
You cannot hear me? Apologies for that. Can you hear me?
Yes.
Yes, on my side also, yes.
Okay, great. There's also a couple of slides that I would like to show. So welcome everybody to today's session. Indeed, it is a very topic. Can someone confirm that that you can hear me?
Yes,
Yes,
for
okay.
me it's okay, yes.
Okay, so it's just my colleague who cannot hear me. That's reassuring. So thank you for joining. As my colleague Ben mentioned, this is a very topical subject. The REPowerEU action plan, which complements the REPowerEU communication, was published this morning. And we actually, just by coincidence, decided to have the webinar today. And therefore, we are still digesting what is being proposed by the Commission in the communication published today. This is the overview of today's agenda. I will give a short introduction to cogeneration and our vision, to be followed by cogeneration best practices that will be kindly provided by our guest speakers today. This is an attempt to showcase how cogeneration can both repower and reheat EU and how CHP technology can actually complement various other clean energy solutions to speed up our decarbonization, but also to ensure security of supply and to ensure that we can more easily and cost effectively phase out Russian gas, which is actually the objective of REPowerEU. This will be followed by a panel debate, and then we'll draw conclusions from our discussion today. So just to introduce COGEN Europe, we are the Association for the Promotion of Cogeneration, and we did do that cross-sectorally and across the European Union and more broadly Europe. The cogeneration sector has set its vision for 2050 already. We are committed to creating a resilient, decentralized, and carbon neutral European energy system by 2050, where cogeneration can actively contribute. This is achieved by empowering European citizens and industry to generate their own heat and power. That will also ensure higher integration and efficient integration of heat, electricity, and gas networks through cogeneration. That is one of those integrating solutions. And so cogeneration does not only enable energy efficiency, but also higher integration of renewable energy sources and a more resilient energy system, because of course, we also provide more flexibility to the energy system, complementing renewable energy and electrification that we see is increasingly promoted. Just a snapshot of our membership. We are a hybrid association representing both national associations and corporate members. When it comes to corporate members, we also we're proud to say that we represent the whole range of cogeneration solutions, but also the whole energy value chain, as both the manufacturers of CHP technologies are represented, as well as the users of CHP, from industrial users to utilities and also to energy service providers that rely on cogeneration to decarbonize energy, but also to ensure security of energy supply. So what is cogeneration? For those of you who are not familiar with the technology, cogeneration uses one input, and that can be any kind of energy sources, from conventional energy sources like natural gas, to geothermal, solar thermal, also hydrogen that is being discussed quite a lot these days, any renewable gases, and less known solutions like waste heat. That can be a fuel input to cogeneration. And then it takes these energy sources and it maximizes its use by producing both heat and electricity at very high efficiency. There are also very diverse applications for cogeneration, starting from district heating, but also actually half of CHP is used by industrial sites to actually ensure process heat for their industrial processes. Hospitals use CHP, and more recently, individual homes have micro CHP systems installed in their basements. So what are the benefits of CHP? Of course, energy efficiency and resource efficiency is the key benefit of cogenerating heat and power. However, in doing so, in using energy sources that are available more efficiently, cogeneration also reduces CO2. As I mentioned before, it integrates energy systems at local level by flexibly supplying electricity, but also efficient heat, and also integrating, in some cases, the gas networks. It also supports electricity grids, and as we see, electrification is more and more taken up, then we will need dispatchable and decentralized electricity production to actually ensure that electricity is available when and where needed. With CHP, we actually reduce we reduce the overall energy costs of the energy system by also reducing grid losses, since CHP is produced and consumed locally. And this goes into more detail on how CHP supports energy efficiency. So compared to conventional technologies like power-only plants and boilers, CHP makes more with less, so it generates 40% more productive energy, as it is shown in this example, compared to an average boiler and an average power plant. It saves at least 10%, as it mandated in the Energy Efficiency Directive, compared to actually the best and most efficient boilers and the most efficient power plants. And then in addition, as it is located next to the point of consumption, it also reduces grid losses, which tend to be quite significant. So then zooming out from the from just cogeneration and looking at the whole energy system, we see that quite a lot of energy is wasted across the whole energy value chain. Looking at the electricity sector in particular, we see that conversion losses are quite significant. So from 400 MTOEs of energy input, and this includes all thermal fuels. Well, of course, we still have coal into our mix, but also natural gas, biomass, biogases. It also includes PV, wind, so the intermittent renewables. From all this fuel input, more than half is wasted as heat that is discharged into the air. And then 22 MTOEs are also lost in the grids just to transport that electricity to the consumers. Just to put things into perspective, the whole heat demand of EU buildings amounts to 192 MTOEs. So if we were able to recover some of this heat that is wasted and put it to use through district heating or use it in industry, then we would already reduce energy consumption, reduce significantly gas consumption, and also make the whole energy system less costly, as well as ensuring that consumers do not pay for energy that is actually wasted before it even reaches them. So how can cogeneration contribute? Of course, cogeneration uses all these fuels more efficiently, and it avoids the waste of heat, actually putting that heat to good use. It reduces grid losses, and it reduces actually the need to reinforce electricity grids, which will become more and more important in the coming years with a focus on electrification. And then, of course, CHP is, you can find it everywhere. As I mentioned before, there are applications in industry, applications in district heating, and more innovative applications in individual buildings. And this is not always acknowledged. We find in EU policy as well as in European Commission strategies like REPowerEU that focus quite a lot on end-use energy savings, which are necessary, but does not focus enough on the whole energy system. And in the current quite serious context of the war in Ukraine, it is of course important to understand that natural gas and gas in general is not only used in buildings, it's not only used in the electricity sector, it's also used in district heating and across the whole energy system. So if we want to have to significantly reduce our dependency on Russian gas, but more importantly, for the sake of the environment, our dependency on fossil fuels, it is important to look at the whole energy system rather than each sector in isolation. So with that introduction, I would like to actually very quickly switch to our case studies today. As I already mentioned, the REPowerEU, of course, focuses on reducing quite rapidly our dependence on Russian imports of all fossil fuels, but natural gas in particular. In that context, I will share a few numbers ahead of the panel discussion, but we have chosen some quite exemplary cases of cogeneration that actually already contribute towards significant energy savings as well as security of supply. So this is the overview of our speakers. So we will start with 2G and the example of Hassfurt city in Germany. This will be presented by Andre Banken. Then we will continue with a case study from Belgium, focusing on biogas, so local production of biogas, which is achieved with the help of CHP. This will be presented by Mr. Iri Jansa from TEDOM and Christopher Stuntz from Cortec Energy. And finally, we'll have a case study from Italy that focuses on heat recovery and waste heat used in district heating, of course, with the use of CHP. And that will be presented by Sabrina Santa Rosa from Turboden. So without any more time wasted, I will ask Mr. Banken to share his slides and give us his presentation.
Yes, thank you very much for the kind introduction. Also the intro on CHP. Let me.
And while you're preparing that, let me just say that we have in Zoom, we have a Q&A function, which everybody, all the attendees can see at the bottom of the screen. So if you have any questions, either from Alexandra's presentation or from one of the case studies, you can type your question into the Q&A box, and we will try to get to all of your questions later in the webinar. So on that, I will hand over to Andre.
Thank you very much. Yes, good afternoon to everyone from me as well. As kindly introduced, I'm Andre Banken of 2G Energy. I'm the international sales manager, and I'll like to give you a little bit of an intro to cogeneration technology for H2 applications. Just one slide about 2G. I try to keep it brief about the company. In case you haven't heard of us, our company is existing since 1995. Nowadays, we are roughly 800 employees and focus on cogeneration CHP systems for all sorts of gasified applications. Of course, also natural gas, but special emphasis on all sorts of green gas applications. So biogas, landfill, sewage, wood gas applications, but also hydrogen, and the capacity from 20 kilowatt electrical output up to 4,500 kilowatt of electrical output. Our company is considering itself a one-stop shop solution provider for cogen applications, so engineering, production, service, and development. And our install base capacity these days is more than 8,000 units in give or take 50 countries. Among the EU members, I would say every single one of them is represented. And the total installation capacity by end of last year was around about 2,000 megawatts of electrical generation capacity. And of course, the same amount of thermal generation capacity likewise. I mean, what a cogen system is, Alexandra already gave you all the facts and figures there. Just let me point to one item. CHP, of course, is heat and electrical power, but that heat can be used in a quite diverse way, kind of ways. So you can use it as hot water, which is the most common one, but it's also possible to utilize that heat as steam production or even as cooling energy via combinations of absorption chiller technology or a steam generator. So it makes CHP application, especially for the commercial and industrial sector, much more versatile, as the type of thermal energy that is actually required on site can be provided in combination with a cogen system. Where it can be utilized, Alexandra mentioned most of that as well. So for us, CHP fits almost everywhere. It doesn't matter if we're in the agricultural sector or district heating, logistics centers, the food and beverage industry, construction markets, retail, hospitals, aquatic centers, and all sorts of manufacturing industries. So basically everywhere where is the constant demand for power and heat at the same time, there is room, space, and the necessity for cogeneration applications. In recent years, especially, this is the 2G perspective, in recent years, especially the two sectors in the middle that you can see here, let me put on the laser pointer, here you can see it, especially these two sectors in the middle had a strong drive. So the food and beverage processing industry, as well as the general manufacturing industry, they have been, from our perspective, become more attractive for cogen application, as both of these industries have 24/7 production, production cycles and need a constant demand for power and heat. And especially on the food and beverage sector, it's a high quantity, low margin business. So every cent on energy costs saved is profit for them. So, but how does that look like in the greater picture? I mean, us being a German company, I picked out a slide from a recently published study. Sorry, it's in German, very quickly. If this is forecasting the gross electricity consumption in Germany until 2050. And if you look from top to bottom, the sectors where the power demand is supposed to increase is the industrial sector, which is quite obvious. Then especially the traffic sector, so electric vehicles, e-mobility. Then of course the heating sector, so district heating, H2 production, grid impact losses, battery storage, charging, and so on. So what you can see here that in 2018, where we had, give or take, 595 terawatt hours of power consumption, by 2050, this is supposed to increase by more than 50%, up to 962 terawatt hours of power demand. And this is just the electrical side, not even looking at the heat demand additionally. In the same while, we have a constant increase of implementation of renewable energies with special emphasis on wind and solar. So here you can see in red in the background, the electricity demand of Germany over the course of 1 year, where there is the peak demand, give or take 80 gigawatt these days. And in green, you can see the nominal average production of renewable energy. So by 2020, we have been at almost 40% renewables in the grid on an average day. So if we look at the long-term development with increases of PV, wind, and other forms of renewable energy, we will have a strong volatility in the entire energy infrastructure, where we have lots of times where we have much more power than it is actually needed. So that energy surplus can be converted and stored in the long term into hydrogen, which means that storage technologies and the flexible use of that stored energy becomes more important. And this is again where cogen technology, where cogeneration systems come into play to address both the increasing energy demand and the increasing volatility in the power grid. So cogen by hydrogen can be a stabilizing factor. To give you also an idea, sorry, again, this is in German. Right now, in Germany, we have, give or take, 80 gigawatt of controllable power capacity, so which is not dependent on weather conditions. But you can see also here from the bottom to the middle, a lot of that is still nuclear and coal power based, which gradually will be produced in the German power market in the coming years. And more of that energy will be switched from nowadays coal and nuclear to gasified fuels. So a typical fuel switch from coal to gas. But of course, in the same manner, we do not only want to have a decarbonization of that power supply, but we also need to address the increased power demand and further have CO2 emission reductions. So there is this movement which is sometimes addressed as content switch, which basically means the existing gas infrastructure will more and more change from a fossil fuel based to a renewable fuel based infrastructure with the injection of biomethane, biogas, biomethane, green molecules into the existing gas infrastructure, as well as hydrogen, both locally produced and imported from overseas, so that gradual more and more of the existing gas infrastructure is based on renewable fuels, so that we not only have a controllable on-demand power supply, but also a sustainable one. How that works is obviously with power to gas technologies. I guess most of the participants here are familiar with how it works. The excess electricity by wind and solar is converted into hydrogen and then either directly used on site, example for charging cars or fueling cars, or in a locally installed cogeneration system where it can work in conjunction with the other renewables, or it is injected into the existing gas infrastructure where it is mixed with green gases coming from biogas plants and biomethane injection facilities to have an overall, as I mentioned earlier, content change in the infrastructure. From the technology perspective, 2G is a gas engine manufacturer, a gas engine-based cogen system manufacturer. It is possible to have that change. So if you have systems that are running on natural gas or biogas today, they can be converted in the field to hydrogen operation. Without bothering you with the technical principles, in general, we change from an external gas air fuel mixture system to an internal one, to a so-called hydrogen injection one. And this allows us to, with the gradual increase of hydrogen and green gases in the overall gas infrastructure, to use and utilize cogeneration system at the distinct installation site for the demands of the customer. Furthermore, it's a highly versatile system because we do not have to consider it as the flipping of a switch, but if necessary, as a gradual changeover. So with increased change of the composition of the gas infrastructure, with the supply of natural gas from different countries, with the additional injection of biomethane, and with the usage of and utilization of hydrogen, cogeneration technology can cope, can match all of that. So it is a future-proof technology that allows, with an increased operational capability, to cover residual loads and also peak shaving, helping to stabilize the public electricity grid. The number of references our company has is increasing. You see here an overview of that, but as initially introduced, we want to focus on the city of Hassfurt, which is in South Germany. And there you basically already have how some envision the future energy infrastructure. So you have renewable energy, which is locally installed by wind and solar and even biogas. Excess energy that cannot be used in the Hassfurt city energy infrastructure is then via an electrolyzer converted to H2 and either stored locally, so they have a 12-hour H2 storage there, or directly injected into the existing gas infrastructure of the local utility. The cogeneration systems then produce the hydrogen-based power on demand. So when there is a gap in power supply by wind and solar, depending on weather conditions, while the thermal energy is injected into the local district heating. You can see a few pictures of the system there, how it is installed. That was done back in 2018. So it's not brand new. It's already in operation for a couple of years. And here again, the quick numbers. So 1.25 megawatt PEM electrolyzer, H2 CHP unit, 170 kilowatt electrical, 200 kilowatt thermal, a 12-hour hydrogen storage, and even a station for the H2 injection into the existing gas grid in case that storage is already full. And why makes that sense in the case of Hassfurt and much more on the greater concept? This is how the energy supply concept of them already looks today. So 10 megawatt of PV already installed, 31 megawatt of wind already installed, 2.35 megawatt of biogas plant capacity installed. So they have wind, solar, and biomass, which is operated with an overcapacity 3 megawatt biogas cogen system. Again, power supplied to the energy infrastructure of the utility, heat injected into the district heating network, which you can see here. So the entire city has district heating available in conjunction with smart metering and the transformer stations, so to better regulate the power supply and demand. And of course, they will add more electric vehicle charging stations. So the city just started with that, but they want to increase that over the next years as well, making the power demand in the city more challenging. So, and to save that excess energy from 10 megawatt PV, 31 megawatts wind, and 3 megawatt biogas, this electrolyzer was installed that I showed earlier in a localized H2 storage, so that the energy, the stored energy, can be converted back into power and heat on demand as required. So this is already existing today. What Hassfurt wants to add in addition to that is an 8 megawatt battery storage with a challenging 10,000 smart meters in shops, in restaurants, in local hotels, local companies, public buildings, to establish a smart grid so that really the management of power supply and demand, not only electrical, but also in heating, can be managed much, much more sophisticatedly. And also a hybrid compensator energy storage shall be included there. So what you can see here is what they're doing is really to try to get more than 90 or 95% renewable energy, both in energy and of course to the degree possible in heating, plus having short-term energy storages via batteries and the better management via smart meters. And on the other hand, the long-term energy storage of renewables via hydrogen, either stored at localized storages or in the city's own gas infrastructure, so that really that volatile renewable energy can be or is available for the city in a safe manner, in a reliable manner, and of course, on the long run, in an affordable manner as well. So that, and cogeneration system, irrespective of if it's biogas or H2 at the vicinity, can play an integral role in compensating for the volatilities which they have here in the future, or that they're expecting in the future. Another project, because I am expecting these slides will be shared with the audience, I will not go into detail with this one. Hassfurt is a citywide solution or a townwide solution. This project here in Esslingen is quarter solution. So in the city of Esslingen in West Germany, where you basically have the similar setup, but for roughly 500 residential units for a new student university campus with roughly 1,800 students on maximum capacity, including office buildings, leisure centers, bars, restaurants, a cinema, and so on, where you have a similar setup, localized wind and solar power, H2 storage in conjunction with cogeneration capacity to even out volatilities, a battery storage that is available to charge electric vehicles, also in conjunction with the local electricity grid, of course, and on the heating side, the heat supply via the cogeneration system to the university itself, as well as the residential buildings, also here in combination with locally installed heat pumps, so that we have a base load and peak load heat demand ensured, and for the deep winter season, just in case, a standard boiler, but this is only really used in emergency cases over there. So to summarize, from our perspective, CHP can be and should be one of the backbones of the energy transition. It's a decentralized supply. That means power and heat is produced where it is needed, when it is needed. It helps to stabilize the grid. So these units are highly flexible to provide power in case of grid fluctuation. So it helps stabilizing the power grid. Therefore, it contributes to the security of supply in general. It's highly flexible on-demand operation, as I mentioned earlier. It's compatible for virtual power plants, so you can operate them in concert with other thermal and electrical energy sources. It is highly efficient, as Alexandra introduced earlier, therefore very economical. It's easy to maintain, as globally trained personnel is available, so it's easy to maintain these units. And of course, it's highly flexible when it comes to the fuel supplied. Hydrogen is a possibility, also so-called waste hydrogen, which we personally receive a lot of inquiries from the chemical industry right now, which are often have unused hydrogen available as a byproduct from their day-to-day production process. Gas engine-based cogen is insensitive to the impurities from that waste hydrogen, so that can be utilized as well. And of course, it's a CO2 neutral technology due to the increasing composition of hydrogen and biomethane in the overall energy and gas infrastructure, so that we really have a reliable and affordable and also a sustainable way of producing electrical and thermal power right where it is needed for the end user base. It doesn't matter if it's a residential, an industrial, or a commercial application. And I know I'm a little bit over time, but that being said, thank you very much for your attention.
Thank you, Andre. And now we switch to Belgium. So I will ask Turboden, I'll ask Tedom and and Christopher to show their slides. Thank you.
Okay. Good afternoon, ladies and gentlemen. Do you see my slides?
Yes, it's
Yes.
okay, Yuri. Yeah.
Perfect. So thank you very much for the opportunity to talk about the cogeneration and the project we delivered equipment for, and our partner from Belgium, Coretec, did the complete job. I will be talking at the beginning about the company, our technology, about the benefit of cogeneration. And then I will hand over to Christopher, who will be talking about the project itself and explain you the benefits of the biogas that has been used in our CHP systems. For those that are not familiar with Tedom Group, we are exporting our technologies to 50 countries. We have close to 1,000 employees, producing around 300 CHP units a year, and already delivered almost 10,000 CHPs globally. We are based in Czech Republic, so I'm talking from Czech Republic, but Christopher will be talking from Belgium. You see our headquarters in Czech Republic, but we have also factory in Germany, in Wangen, where a couple of years back in 2016, we acquired the company Schnell, and the numbers that we are presenting are combined Tedom and Tedom Schnell. We are exporting and have subsidiaries all around the world, the most importantly Czech Republic, Slovak Republic, Poland, Germany, and United States. In the other countries, like in Belgium, we work with our business partners that are providing sales and services of our equipment, and even installation and operation. The portfolio of the CHP is starting from 20 kW up to 4.5 megawatt. The portfolio is designed for all gases, meaning nature gas, but also what is the topic of today, other renewable gases, biogas, coal mine gas, sewage gas, any gaseous fuel with methane content, but also we are ready for the hydrogen mixture that is available in the pipeline and will be in next 10 years available in certain content in the current infrastructure. The portfolio is ready for the mixture up to 20% of the hydrogen already. So if there are some questions about the readiness of the technology, we are ready for the hydrogen that will be available in existing infrastructure. And as time goes and there will be probably parallel infrastructure for hydrogen by the time the complete pure 100% hydrogen technologies will be available even in our portfolio. But that's the question about the next 5 to 10 years, as was even presented in previous presentation. One slide where we see the big potential of CHP, and it was also mentioned already, it's the flexibility of the CHP, of the whole portfolio, not of the individual CHP itself, but when we will combine the portfolio together, we can provide the balancing of the network. And we already did the pilot project for Czech transmission system operator, where we aggregated one block and certified for ancillary services, and already providing regulation, negative regulation for the TSO system operator. And this system works on biogas and landfill gases, where we can stop production and down-regulate the power output to the grid. And by these systems, we are helping TSO in the time where the electricity is not needed, especially in the time where there is a lot of renewables connected to the electricity network, solar and wind, and they need to be balanced. This is important part of the CHP for the future, and will play more and more significant role as time goes further, because we will need to balance the grid with more unstable sources being connected to the network. Being able to doing those more advanced features and providing services that are important for the CHP owners, we acquired also the electricity and gas operator, or not operator, it's seller. So we are offering gas to CHP owners and buying back the power. So CHP clients, owners do not need to care about the trading and stuff related to the operational stuff, and we can do one-stop shop services for them, including financing and operating of the CHP sources. Now we are getting to the project. We used for the project in Belgium Quanto system, which is shown on the picture. And here is exactly the picture from the site, where you see in the back the biogas plant, and in the front 2 CHP systems from TEDON, which are based on MWM engine. First unit was delivered in 2016 and is based on MWM engine 2016. Second was delivered in 2020 and is based on the newer type of the engine, more efficient. And both CHPs were delivered, including the treatment system, which is filtering the gas and providing the cleaner gas for CHP. 2 units are connected, of course, to the remote monitoring center. You see the picture in the middle of the slide. This is 24/7 service, where we see if the unit is running or not. and providing the support to the clients to make the system up and running anytime during the night. And on both sides, you see the screenshots of the e-service, which is our monitoring system. You see that both units were, at the time when I was preparing this presentation, were up and running almost to the full speed. And I just collected important data from this screenshot, which is showing when the unit was commissioned, how many days is in operation, and rough uptime, which is calculated total hours and the hours when the CHP unit actually ran. You see the numbers from 95 to almost 98%. And if you consider that for servicing itself, changing oil, sparks, plugs, and other components of CHP will take 1 or 2% of the total hours. The units were running almost non-stop. So it's a very good job for Corretec team in Belgium. And by this, I will hand over control to Christoph, who will tell you more about this project from their perspective as operator. Christoph, it's up to you now.
Yes, thank you, Yuri. I try to control it. Yes, I can. Perfect. Great. So thank you, Yuri. So hello, everyone. I'm Christoph Rostens, responsible of the thermal business unit in Corretec. So before detailing the OSHA project, I just would like to introduce quickly Corretec Energy. So we are located in Belgium, near Liège, and our mission is to improve the competitiveness of all our clients by optimizing their energy costs. So for that, we have two main parts in the company. One in relation with all the projects for which we study, finance, implement, and provide all the complete maintenance and the operation, also the remote monitoring of high performance production system, of course, such as CHP unit running with natural gas, but more and more with renewable gas, and also are involved in biomethane project. And on the other side, we help all our clients in their energy strategy for the purchasing and the sales, as well as for the trading of the green certificates that are generated with the production of electricity through CHP units in Belgium. Yes, we have dozens of reference, mainly in Belgium and especially in Walloon-Region or in Brussels. So in particular, concerning CHP units, we have integrated no more than 70 units until for the bigger one, until to 3.5 megawatt electrical power. Of course, including several in collaboration with TEDM, and all these units are currently monitored by our maintenance service. And we, in recent years and current project, but also those to come, have increasingly concerned engine running on biogas rather than natural gas. Now concerning the OSHA Energy biogas plant, so in which Corretec is a minority shareholder and also the integrator. We took care, as Yuri said, in partnership with TEDM, of the integration of these two units in container, and also associated with the treatment of the biogas for each. Corretec was also involved to realize the medium voltage and the low voltage electrical works on the side, as well as the wool system for the main regulation of the wool plant for remote control. And after the first CHP unit installation, heating network has been done. So as Yuri said, the two units are in container, with each one full power of 600 kilowatt, but the capacity of the digester is limited to approximately 1,000 kilowatts. So that's why in your example, you say that the two CHP units are not running at full load, but it's designed like this to have a little margin. So it's just normal. The actual annual production for combined unit is 8,000 megawatt hour. So they produce electricity with a quite good efficiency of approximately 40%. And it also is valorized as of hot water. I can have the control. Yes, so they produce, as I said, electricity and it as hot water. All the production is dedicated for the local consumption. And the heat is, of course, valorized in the digester, but after that, with the heating network of approximately 2 kilometers, the hot water is valorized to heat a nursing home. And this allow to the nursing home to have an economy annual saving of more than 150,000 liters of fuel per year. The main part of the electricity is sold to the grid, which is, of course, the main income of the whole plant, in addition of the green certificates. So the digesters are fed with more than 30,000 tons per year of agricultural waste within a maximum perimeter of 20 kilometers around the site, and also with waste from the agro industry. And all the remaining digesters are used as local fertilizer by the farmers in the surrounding fields. This installation has also been designed to have, I would say, a minimum impact on the landscape. So it's located behind the woods. It's also, we have also a part of the digester that are constructed below the ground level. And annually, it contributes to a saving of a bit more than 6,000 tons of CO2 per year. Yes, that's it. Thank you for your attention.
Thank you, Christoph. Just one note from my side at the end. This full case study is available at our website, where you can see it, TEDM downloads, and much more case studies for the biogas, renewable gas, and other applications that are very up to date. So thank you very much from Coretech and TEDM side.
Thank you, Jiri and Christopher, for a very informative presentation of the Océan Energy biogas plant. And we have one more case study to look at before the panel discussion, and that comes from Turboden. Sabrina Santarosa is joining us now, and I hand over to you, Sabrina.
Yeah, hello. Let me know if you hear me and you can see my screen.
We can hear you.
Okay. So thank you very much for this opportunity. I'm Sabrina Santarossa, sales manager for industrial heat recovery in Turboden. And I will present you today plant that we have here in Italy, very near to our office. First of all, I will also introduce briefly our company. So Turboden is an Italian company that is in the market since 1980s. And we are producing organic Rankine cycle units that are like small steam turbines that uses anorganic fluid. I will not go too much into detail into the technology, but if you have any question, please do. The size of our product ranges from 500 kilowatt up to 20 megawatt with a single shaft. And the RC can be used in connection to different kind of sources, In any case, we need a thermal heat source. And today I will focus on industrial waste heat that is available from the several industries, the hard to abate industry. We are not producing only ORC. In the last years, we are also producing large heat pump. I will briefly also talk about this, and gas expander. And since 2013, we are part of Mitsubishi Heavy Industry Group. And here are our experience. So as you can see, we have more than 400 ORC plants installed worldwide. Most of them are in Europe, but we have also some ORC in North America, in Turkey, in Southeast Asia, in Japan, in South America. So we can provide everywhere our technology. And as you can see also, we have sold 2 gas expander and 1 large heat pump that will start up in the next month. As said, our technology can be connected to waste heat from the industry. And so we can help the industries to reduce the energy consumption from the grid. So our products can be combined with different heat sources that can contribute to decrease the CO2 emissions. We are usually, our technology usually is in the scope 2. So we help to reduce the energy consumption from the grid and not a direct reduction of the CO2 emission of the industry itself. This is a scheme of a waste heat recovery plant. So we have an industrial process that could be, for example, a cement production, a steel production, or a glass production. And all these kind of industries usually have a gas, hot gas that are not used. So there is heat inside the hot gases that is wasted. So there is some waste heat from the process that can be used and can be transformed into electricity and low-grade heat. So the technology, the ORC technology, transforms heat into electricity and low-grade heat. Some characteristics of our technology are that it's a very simple technology, automatic, and can be, let's say, is not typically supervised, and can be remotely monitored. We don't consume any water, so we have also this benefit of not consuming water that is becoming an issue in most of the countries. And also the activities, the maintenance activities are reduced. It's an easy, as said, easy technology, but also easy to integrate in the industrial process. And it is a flexible technology, so meaning that it can work down to 10% of the load and without any, let's say, problem. The availability of our fleet is very high, is higher than 98%. And also the life is a long life, more than 25 years. The oldest ORC that we have in operation has more than 20 years. Also, as it is a sustainable technology, meaning that it can increase the sustainability of the process, because as already said, it reduces the energy that is consumed inside the plant. So we do energy efficiency. And so this also helps to reduce the cost of the production. There is a global reduction of CO2 emission, not in the plant, but globally in Europe or in the world. And also very important in these days is the fact that you can assure an independent production of electricity with a fixed cost for more than 20 years, because you are producing the energy with something that you already have. You don't have to burn anything in addition to what you already have to produce this electricity. And so you are less exposed to the volatility of the energy, the electrical energy market, like we are seeing in this last month and during this last year. Going more deep into the project that we are presenting today, this is an heat recovery project in a steel factory. They have an electric arc furnace, and we are recovering the heat from the excess gas of the electric arc furnace. The customer is Henri Martin, is a steel mill close to our office, and the plant is in operation since 2016. So 6 years now that is operating. The size of the ORC is a 2 megawatt ORC. What is interesting of this plant is that we are not only recovering heat to produce electricity. This actually happens during summer. In winter, the heat that is recovered is sold to the local heating district network that is owned by A2A, that is one of the biggest utilities in Italy. And so in summer, thanks to the ORC technology, we can light up to 700 houses. While in winter, thanks to the use of the heating district network, we can heating up 2,000 houses. This is equivalent to avoid to a CO2 avoided emission of 10,000 tons per year. That it means not to burn 1.7 million on standard cubic meter per year of natural gas, which is quite important to underline in this period. 2020, we also, let's say, developed together with A2A, with Henri Martin, also with COGEN Europe, with RINA, and with CSMT, a new project that is under the LIFE program. So it is a funded project to increase the heat that is sold to the heating district network. So to help to further decarbonize the heating district network that is present here in our city. And this is possible thanks to another technology that we are providing, that is the large heat pump. So the new scheme will be the one shown here. So we have the electrical furnace and as you can see here, the primary circuit where there are the excess gas. There is this production of the heat that is used, as I told you before, in summer to produce electricity, and in winter is sent to the district heating network. We insert the large heat pump in the secondary circuit. So the low temperature circuit that is used in the electrical furnace to cool the electrical furnace, and usually the temperature of this water, because they use water to cool the electrical furnace, is a low temperature, let's say low medium temperature, but surely lower than what is required by the heating district network. So thanks to the large heat pump, we can increase the temperature of this heat available, this waste heat available. Also, this is waste heat at low temperature. We can increase the temperature of this water and send it to the heating district network. It's a little bit more complicated than this. I will not go too much in detail because let's say the large heat pump is flexible, and it is designed to give either 95 degrees hot water temperature or 120. So let's say since the process is not stable, we can assure a stable temperature to the heating district network depending on let's say, the moment in the process that is in so-called power on or power off, if it is working or not, basically. So the heat that we will deliver will be an additional of 6 megawatt thermal to the heating district network. Right now we are delivering 10 megawatt thermal. So we are increasing of more than half of the actual thermal power. This is one of the plants that we have, but in heat recovery, we have other at least 20 plants in operation or under construction. Here I have reported the list of the complete list of references in the cement industry, in the glass industry, and also in other steel or metals production. So this to say that we have experienced and we can propose this kind of solutions not only in the steel industry, but also in the other harder to abate industry that have waste heat. So thank you very much for your attention. And if you have any question, I will be happy to answer.
Thank you, Sabrina. And I think actually because the time for the presentations was a little bit more than we had foreseen, I think it would be probably a good thing if we now move as soon as possible to the panel discussion, because that will help to put the cases that we've looked at in the context of the REPowerEU plan. So I would invite Alexandra and Andre, Giri and Marco Baresi from Turboden to join us if you're able to do that. And I will hand over to Alexandra to lead the discussion.
Yes, thank you very much, Ben, and thank you to the speakers for presenting such compelling case studies. Now, the key question for today is, of course, REPowerEU. So the panel debate will focus on, are we ready to REPowerEU? From the measures that you have seen proposed, is that sufficient and cost-effective for Europe to be able to phase out fossil fuels in general, but also face the immediate challenges that we have in terms of security of supply and quite high energy prices? Of course, the CHP sector is to some extent a user of gas, so it is impacted by the energy price crisis. On the other hand, cogeneration is also a technology that helps save energy, including all gaseous fuels. So we see this from different perspectives, of course. So one of the questions is, how do you see REPowerEU? Both what the Commission has proposed on the 8th of March and to the extent you've already seen the documents published today, the action plan that was actually proposed today, and how can the cogeneration sector actually contribute? Are all these case studies that were presented today, are they scalable to actually have a significant contribution towards REPowerEU, but more generally our longer term climate and energy objectives? So maybe I'll start with introductory statements, maybe 2-3 minutes by each of the speakers. And I will let Andre start.
Okay, yes. Thank you very much. I mean, if you look at the fact sheets of REPowerEU, which just published earlier today, so I had a quick look at them before the start of this webinar. And I mean, if you look at the long to medium term targets, I believe that the application of cogeneration technology, as it was shown today by all three presenters, can pay a contribution to that. I mean, we speak about energy resilience. Yes, of course, a diversification of fuel supply, both by obtaining gasified fuels from other suppliers, and of course having your own production capacities by biomethane injection, by the increase of biomethane injection, but also by the increase of the utilization of hydrogen. I think they speak about the hydrogen accelerator to have 17.5 gigawatt by 2025 of electrolyzer capacity, if I saw it correctly. And I mean, to make it handleable, it is, from our perspective, essential to achieve those items, to make the energy available where it is needed. And some of you might know the German problem of massive renewable energy overcapacity in the north, while the heavy industry is located in the south. So making that diversified energy available where it is required by renewable means, to make that renewable energy available, using the existing infrastructure, the existing gas infrastructure, makes absolutely sense. And having the local generation units where they are contributes to that. It's a small units that can easily be switched on and off within minutes if so required. And as I showed, they can be run with a multitude of fuels or fuel compositions, including renewable fuels such as biomethane and hydrogen, which will play a larger role in the short-term future. And of course, and some of the questions in the Q&A that were addressed, not only in the electrical supply, but also in the thermal power supply, especially on the high temperature level as well, that is often required by the commercial and industrial sector.
Yes, thanks for that. Then Marco, I will revert to you. Also, again, the same question, does REPowerEU deliver overall, given the objectives, and how can CHP contribute? And has this contribution been taken into account in the strategy?
Yes, thank you, Alexandra. I've seen briefly the publication today, and there are three main pillars. The first one is to save energy. And so CHP, waste heat recovery, energy efficiency, in principle, is very focused on this package, save energy. The second is diversify supplier. And the third is the acceleration of green energy transition with a massive penetration of renewable. But let me start from an obvious statement. CHP technology is the simultaneous production of electricity and heat in the most efficient way. Sorry for this redundant statement, but it is thermodynamic. It is important to remark, especially in this period, with the current debate is mainly focused on PV, wind, and electrification of heat. Why? Because most of the industrial processes like paper, food, or ceramics need power and heat at certain temperature simultaneously. So it is very difficult to find an alternative and efficient way. So CHP technology is an efficient technology, by the way. Starting from this statement, the other question is related to the fuel to be valorized with the CHP. So we have seen example with hydrogen, with biogas, biomethane, but we have also solid biomass and geothermal as well. We, as Tudoroiu, have an experience of more than 300 CHP plants in operation with biomass and geothermal. So we are specialized in CHP with renewables. And if I have the possibility to deviate a little bit to this specific CHP, we have seen in the presentation of Sabrina also another relevant point, so the role of waste heat recovery and waste heat. That it is mentioned in the Save Energy package with as one of the possible support. Recovering the waste heat from industrial processes is a virtuous and efficient opportunity because we have the possibility to generate heat, for example, for the district heating, or to generate electricity for self-consumption, or to generate both. And so is an opportunity we have seen in the steel industry in Henri Martin. It's an opportunity for more flexibility because you can choose to produce electricity during hot season, for example, or in this specific situation where the cost of electricity is high, we can balance the generation of heat or electricity. So this is a situation, a technology useful for steel industry, but also for the hard to abate industry like cement, glass, or other. And another special remark: this CO2 or this power and this heat are CO2 free. So we have the possibility to valorize an excess heat that otherwise is wasted in the atmosphere. Let me finish with some data. The white paper Thermal Energy Harvesting estimated 150 terawatt-hour of electricity that can be generated only recovering from waste heat. That more or less is 5% of the electricity currently produced in European Union countries. So it means that we have a lot of opportunity to recover the waste heat and could be a relevant part for the REPowerEU, in my opinion. Thank you.
Thank you, Marco. And indeed, what you are pointing out is that we shouldn't look at the various energy solutions in silo, but look more and more at synergies between the clean energy solutions. And I think that's one of the gaps in REPowerEU. We focus on a PV strategy, and then on a hydrogen strategy, and then biomethane strategy, and the electricity sector short-term versus long-term measures, but we don't look at how these energy systems and energy solutions integrate and can deliver more cost effectively in combination or complementing each other. Then I'll turn to Iri, also to share his views on the topic.
Sure, thank you very much. So I will mainly add up what has been already said by the speakers before me, but the measures are mostly relevant. The increase of biomethane H2 production means that the technology CHP is already here. We just will need to have the more greener input. But how we will get there to 100% green is not a question about immediate actions. It will be continual growth, continual share increase of the greener gas coming to the technology that is already here. And its main benefit, especially with the reciprocating engine, is a quick possibility to change and regulate the network, regulate the disbalances in the network, and this needs to back up renewables that are not possible to be regulated in the immediate time. So this technology needs to back up clear renewables, and in the next years, the more greener fuel input will make this technology in line with the REPowerEU strategy. So this is absolutely in line with what we are doing. Another point of view is savings. as we see, the impact of these savings is not very big in the analysis. And when we are looking at the strategies and Fit for 55, we already see that the consumption is growing, and it's growing ever since. This is something where we need to not change the strategy, but probably change the mindset, because more we are saving, more we are consuming. And it's not only about CHP, about electricity, but all the other technologies that requires other resources, not only gas, not only hydrogen, but all the resources of this planet. So this is not mentioned at all. It's more my personal message than the CHP industry message, but this is completely omitted.
Yeah, indeed. I mean, we are also very much focused on overall system integration and looking at the overall system so that we ensure that there's no rebound effects. One of the potential rebound effects and negative effects of this push for electrification is, of course, that the electricity sector uses gas. So if we don't try to minimize energy waste and produce electricity as efficiently as possible, then we might electrify and end up consuming more gas than upstream than we do currently. So those sort of interactions between the various energy vectors need to be taken into account. It's not that we switch from a gas boiler to a heat pump that gas consumption will necessarily disappear for that demand of heat. And I actually have a question here. We're close to the end of the webinar, but I would like to take one of the questions that was asked. Let me see. So the question revolves around how CHP interacts with the renewable and energy production, and how do we ensure that CHP does not interfere with PV and wind generation. And I mean, from our perspective and the modeling that we have done, there is not such a danger, neither in the short or medium or long term, as CHP normally displaces less efficient boilers and less efficient gas power plants. But maybe one of you can react on that, and perhaps there's a way to actually prevent that through regulation. So have a market design that ensures renewables go first and then CHP goes next, and then we have less efficient sources that come in. Andre?
Yes, I mean, if we look at the energy supply infrastructure, even today, you know, wind and solar power are produced when there is wind and sun. So it is a volatile source. So they need to be either utilized immediately when produced. So, and we mentioned that now a couple of times, stored or made available by other means, stored either short-term by batteries or long-term by converting it into hydrogen. So in that sense, this is already or is going to be the primary source of energy production. I don't see any risk at all that power generation by CHP is interfering with that. And we had this already here. By having this very decentralized approach, by having hundreds or thousands of units on the ground in different areas, it is possible to either control each unit individually or combine them as virtual power plants. So to control them as one centralized power facility, and it is able to switch them on and off within minutes. We're not talking about large centralized power stations that take hours to ramp up and ramp down, where we're talking about minutes here. So a classic CHP system, and I'm talking about an engine-based CHP systems. I mean, they're ones based on fuel cells and turbines, of course, as well. I'm talking about engine-based ones now. You bring them from 0 to 100 within 5 minutes, and of course, back again. So it all comes down to power demand on the one side and the supply management on the other side. And there was already a question in the Q&A about how we see the future development of operating times, which I tried to answer. Yes, it will most likely go down with the increased capacity of solar and wind, but it becomes even more important that this backbone or this secondary power supply by cogeneration at a minute's notice is available exactly when we experience the power supply drops, when in whatever region in Europe, because the grid is fully interconnected. In whatever region of Europe, the power production level is dropping, while worst case scenario, the demand is increasing in the same manner. So given that a proper management of supply and demand is there, yes, renewables can be treated as the primary power source and cogeneration system, because we always bring in the heating side as well as the next one to follow immediately due to the high efficiency rates, irrespective of the fuel type. And then of course come this offset of other power sources. So I don't see in that sense any risk at all. These two work in concert and not as opposed to one another.
Thank you, Andre. And we are approaching the end of the webinar. I'll just give first Marco and then Iri maybe a minute to comment on exactly where CHP fits into the big picture. And then I can also comment, as we do have some quite detailed numbers on CHP contribution as well. So Marco and then Iri.
Yes, I agree with Andre, and focusing mainly on the industrial sector, the manufacturing sector, the integration with traditional CHP and the other sources that we mentioned in the renewable and so on is the way for the future. I have only two remarks concerning the REPowerEU. The first one is the role of the energy audits. In my opinion, I've seen that it will be reinforced the application of the energy audit, the implementation of the energy audit results. So, in my opinion, the association must work on that. So, in order to push for the implementation of the result. So it means to do investment in energy efficiency and not only to do the energy audit. And the final remark is related to the energy efficiency first principle mentioned also in REPowerEU. Currently, in my opinion, this energy efficiency first principle is mainly focused on the high level of investment. So we are talking about millions of euros of investment. We have to, the situation is need to do the approach for all the investment. And in this case, the application of the energy efficiency first principle will allow to apply cogeneration, to apply renewable, and so on.
And next, final remarks by Iri.
Yes, I can confirm what has been already said. If we are accustomed to the power as a utility, which is available without interruption, renewables couldn't manage it without CHP, especially with the fast regulating power source, which is gas engine. So if we are ready to accept that we will have the power only in the summer when it's shining and when it's wind blowing, then fine. But I think in this century, no one will be able to accept that. And for this perspective, we need to have some backup, and this backup is CHP.
Thank you for that. Yeah, as promised, I can also share some numbers on how CHP contributes in general, but also how REPowerEU, Repower and Reheat EU can be achieved through cogeneration as well. So today CHP already delivers 11% of electricity, 16.5% of heat, and it actually contributes up to 70% to district heating. This achieves quite high energy savings, as well as that translate into up to 250 million tons of CO2 avoided. That's equivalent to the annual emissions of 100 million petrol cars. And then for 2030, exactly, we do not say that CHP will be the solution for the energy system. It's one of the key solutions that can contribute. So for 2030, there is potential for up to 20% of electricity to come from CHP and 25% of heat to come from CHP. And that's CHP that uses increasingly low carbon and renewable energy sources. So there will be a shift in the CHP fuel mix as the whole energy system moves to cleaner fuels and more diversified fuel supply, of course. This will ensure at least 350 million tons of CO2 avoided. That's about a third of the additional efforts required for Fit for 55. And about 20% of EU's upcoming energy efficiency target. But then indeed moving to REPowerEU and translating all of this into BCM units, we do know that the REPowerEU objective has been set to 155 BCM of reduced of Russian natural gas imports, which must be reduced by at least 2/3 already this year, if not this year, in coming years, and fully by 2030. So how can CHP contribute here? Already today, with the data that we have from Eurostat, CHP saves about 15 BCM of natural gas. That's 10% of REPowerEU objective, and it's more or less equivalent to the behavioral measures that are proposed by the Commission. So turning down thermostats and reducing our own energy consumption. This is indeed a good objective short term, and that can have rapid effect, but it's not really measurable, and it's not really something that can be implemented very easily, because of course it's voluntary. So in the short run, what we actually suggest is to safeguard this existing CHP capacity, because if CHP plants start going offline, then we will end up using more gas, needing more gas to be used. Then for 2030, of course, new CHP and refurbished CHP or modernized CHP has quite a lot of potential, and that could deliver between 20 and 30 BCM of gas. So that's at least 20% of REPowerEU objective. This is equivalent and complementary to one of the measures that the Commission proposes, which is deploying 30 million heat pumps. As mentioned by most of the speakers today, CHP is definitely complementary to electrification and the uptake of intermittent renewables. So it's a measure that will be needed to actually ensure the cost-effective implementation of REPowerEU as well as Fit for 55. So in terms of recommendations, we of course encourage a greater focus on energy efficiency first across the entire energy value chain, and also focusing not only on end use, so on demand, behavioral change, but also on efficient energy generation. Then the integrated approach to energy systems that doesn't only focus on electricity and electrification, but also focuses on how we can establish synergies at local level between electricity, heat, gas systems. We are also insisting on a robust impact assessment that take all the cost-effective solutions into account, including, of course, CHP. And we have more detailed recommendations on CHP, but that is to be discussed, of course, in the coming weeks and months as we have the time to actually understand what the Commission is proposing and what also the other EU institutions think about REPowerEU. With that, I think I will have to close it here. I'll thank especially our speakers, as well as the participants that have joined us today. We've had in the beginning more than 70 participants. So thank you very much for joining. And indeed, if you have additional questions or comments, you can of course contact us as a follow-up. Thank you, everybody, and have a good day.
Thank you, Alexandra.
Thank you.
Bye.
Thank you very much.
Thank you.
Have a nice
Bye-bye.
afternoon.
Thank you.
Bye.
Bye-bye.